In many ways, alchemy can be considered a proto-science, the predecessor of modern-day chemistry. This blend of magic and scientific knowledge was shrouded in superstition and secrecy. Like modern scientists, alchemists attempted experiments in hopes of creating a measurable, reproducible change. However, magical rituals, incantations, and spells would often form part of their work. The goals of European alchemists were equally unorthodox. Many dreamed of discovering the mythical philosopher's stone, an object with the ability to turn base metals into gold. Others hoped to prolong their lives through the use of magical elixirs. From this strange overlapping practice of magic and science, alchemists produced some genuine scientific breakthroughs, including discoveries about metallurgy, basic chemistry, and pesticides.
It was Ernest Rutherford and Frederick Soddy who first suggested a process called radioactive decay. Atoms emit radiation. In the process, they are spontaneously transformed into atoms of new elements. This change from one element to another, called transmutation, had obsessed alchemists in the Middle Ages. Rutherford and Soddy claimed that transmutation occurred naturally during radioactive decay. Radioactive decay, however, involves a change in the nucleus itself to produce one or more kinds of radiation. Consider radon-212 with 86 protons and 126 neutrons. When this atom undergoes radioactive decay, an alpha particle is ejected, producing a major change in the nucleus. The nucleus that remains has become polonium-208. In other words, from radon, the emission of an alpha particle results in a transmutation to polonium. Now let's look at an element that radiates beta particles, such as carbon-14. You might ask, how is it possible for a nucleus that consists of positive protons and neutral neutrons to emit a negatively charged particle? During radioactive decay, one of the neutrons in the nucleus changes into a proton and an electron. This electron, or beta particle, is emitted from the nucleus. The nucleus that remains has one less neutron and one more proton, which transforms the atom from carbon to nitrogen. Let's watch it happen again. A neutron changes into a proton and an electron, and the electron is ejected from the nucleus. The third form, gamma radiation, may occur by itself, but more often in the company of alpha or beta radiation. The isotope phosphorus-34, for example, is radioactive. When it undergoes radioactive decay, it releases a beta particle, as well as a photon of gamma radiation, leaving behind a new nucleus, which is an isotope of sulfur.